Hi everyone, welcome back. In the last video we have tried how this DenseRLOF optical flow is working, and in this video we are gonna get into the details of the functions it's using. There are some parameters we can assign in this class, so we are gonna see how they are working. Actually, if we check the documentation, there is not many information about the parameters of this class. So I have searched how they are working and I already learned, and I'm gonna transfer how they are working. Okay. We can switch to the code part. Actually, this is the code from the previous video. I just extra added to see the default values of the class. So if we run the default of with the default values, this DenseRLOF optical flow, we are gonna see this result, which we are always using in our tracker videos. And these are the default values of the member functions. Actually, now we can a little maybe make bigger. We can check the video. Actually, we are gonna see, you see there is moving object, but there is nothing changing, so it's not giving me the vector like other optical flow classes. So it's not detecting the balls. Of course, there are some ways if we set the parameters correctly, and we can see the ball movements also. But why this is happening? Because actually this DenseRLOF optical flow is designed for a real world example. So most of the cases this is working for human moving and car or kind of big objects are moving. They are designed the parameters in the default in for these cases. For example, if this player is moving, you are gonna see if this stick is gonna show me the moving vectors, motion vectors. If I think player moving more, you see is giving me the vectors, but for small balls is not giving with the default values. Actually, there are some ways we are gonna see with the member assigning the parameters. Okay, but for the default one, maybe since we don't see any result, maybe in a moment I can make it free, so we can check when we change the parameters. Okay, let's start with this K. Also, actually these are there is an interpolator algorithm, and this K, sigma and lambda is just some parameters of that interpolator algorithm. So we can just basically set the first one, which is epic K, and here the default value we see 128, and we can try this. Actually, if we go to the documentation, by the way, default one is 128, just right here, and do not forget, if we go to the documentation, we are gonna see it says lower values would make the interpolation noticeably faster. So if we put the lower, the speed is gonna increase. But if we think little bit, if something is getting faster, I think accuracy is gonna getting down. We can try with different parameters lower than 128, because we already checked it's giving me nothing. But if you just put a little lower value than the default one, let's see how this is working. Okay, you see there are many noise, there are many wrong motion vectors. So if you increase the value of this epic K, maybe you are gonna get faster result, but at the same time you are gonna lose your accuracy. If your background and your motion, your moving objects are so clear, so maybe in some cases you can decrease the default value. But if we check the explanation in here, it also says usually it should be around 120. So the suggested one also this value. Okay, this is the first one. So we can remove this, we already learned. So this epic sigma we can try now. Maybe we can go to the documentation again. In here, what it says high values can help preserve fine details, lower values can help to get rid of noise in the output flow. So in here maybe we can expect the higher value maybe let us to find the balls. So the default one 0.05, maybe we can try a little higher value, which can be 0.1. Okay, the default one of this, by the way, it was 0.05. So we are just assigning now 0.1, and let's see the result again. With default values, just keep in mind we don't see any motion vector for the balls. Let's see with this one. Okay, there are some noise coming, but if we check in this moment, it's giving me at least there is a motion vector for the ball, and it's correct. Let's little continue more. Okay, I didn't. Okay, one more I get in here. Maybe let's continue more. It will give me or not. Okay, it is giving me one more. For the red one I didn't check well, but I think it's not giving maybe. For the white one we are getting in some cases correct results, because when increasing the value, lower values is gonna get rid of the noise, but higher values will preserve the fine details. So maybe in somehow it's just detecting the contours of the balls well, and it's giving me the correct result for this case. So at least this one not totally fine, but we at least get correct some correct information for the balls. This epic sigma also we can switch. Okay, the next one is lambda, and just paste here for setting. The default value for the lambda is 999, and here we can go to the documentation again. It says it should be in the range of 0 and 1000. If you give any value more than this or lower than 0, let's try maybe. If the default, let's try to give 2000. Let's see how it's work. Okay, it crashes because the not the suggested, but the interval, the boundaries between 0 and 1000, so you cannot give above or lower than this interval. Okay, then this is what this one is actually doing. This is just decreasing this value is gonna increase the noise. For example, if we set the default one, by the way, we missed that one, but the default I think 999. So if we set lower than that, let's set the lowest one, for example 1, and we need to see now more noise, because the logic behind is like that. So I'm expecting now I should see many noise around the moving object. You see here there are also always coming some noise, but at some points actually it's also giving correct results. There are some trade-offs, but mostly it's giving me wrong results, because decreasing the lambda, increasing the noise. In the opposite case, if you increase the lambda, you are gonna decrease the noise. This is working in that case. And we can switch to the new one, which is this FGS, lambda, and sigma. These are this one maybe we can talk together. This one just setting the smoothness of the background, I can say, and the other one is just setting and arranging the contour edge preserving. This is setting that one, and this is setting the background smoothness somehow. Let's see, is there any documentation? There is no explanation in here, so we don't, for both there is no explanation. So we can try, but since my background is already smooth, changing this lambda is not gonna give me any difference, I think. Maybe first of all we can see the default value of this FGS. The default is 500, so maybe we can try, let's try 1, if it's gonna change something or not. I guess putting really less than the default one, which is 500 or above, is not gonna change much things, because my background is already really smooth. So I'm getting the same results with the default one. There is nothing changed. Let's see the player. Okay, I also see well player movement with the default. Let's try again. Okay, it's giving me similar results. So default 500, we set 1, nothing changed. Maybe we can set it to the 1000. Maybe just because of the background, in my cases. But if your case is a noisy background, you can little play with this parameter. So this FGS lambda, nothing changed in my scenario. Okay, we can switch to the sigma one. Sigma, the default is 0.5, and the lower values of this sigma is gonna try to find more details. So setting this FGS sigma lower is gonna try to detect more contours and it's gonna try to get more objects. But of course, at the same time, maybe this is gonna increase the noise. Maybe if we set really small value, which is 0.01, by the way, the default value was 1.5, so we are setting now 0.001. Let's try how it's working. Okay. About the ball, I didn't see any changement. But in this scene, I remember it's also detecting before the this stick. I think it's gonna detect now. Oh, no, let's try with the default one. I think in this case it was detecting the stick. Okay, maybe this case we couldn't understand very well, couldn't compare well, but let's try to set a really high value. For example, the default was 1.5, very small, so let's set it to the 1000. Now the expectation is it should detect really clear objects. So my expectation, okay, it was already not detecting the balls. Now I also expect it's not gonna detect well the user, the player. Let's try. In these times it should already give me some results. You see, there is no detecting well. It's so small vectors, not like the default one. So it's little decrease the detecting accuracy for the bigger objects also. So setting this value to the high. Okay, even here I remember for the default one it was longer vectors. Now it's getting small because we increase this sigma value higher. So setting this higher will detect really clear contours. If setting this small, it's gonna detect many even small some contours. So this is the expectation of this parameter. And get forward and backward parameter. Actually this is the behind of this, there is an algorithm. Actually, maybe you can imagine by just think there are two scenes coming after each other, scene A and scene B. So first of all, there is a this is checking from A to the B scene, and then is checking also B to the A. So there are two kind of forward and backward. So in both cases it's trying to detect the motion, then it's getting the information for both cases and it's deciding at the end there is a movement in here or not. Let's check to the documentation if there is any explanation in here. I didn't see well here. This is belonging to the step, so there is no explanation for this forward and backward. But setting this value to the lower values is gonna also increase the accuracy. So maybe increasing accuracy is not good things. It will be getting difficult to detect motion. So it's gonna try to get really clear motions. For example, this the default value, let's first of all learn, is 1. If we try to set it a really low value, my expectation is gonna, this is by the way a threshold, is we are calling this as a threshold, forward backward threshold. If you set it a really low value, for example, let's try maybe 0.1, so my expectation threshold is really low, so detecting the moving objects is gonna be really difficult in this case. Let's try. So again we are gonna go to the part of the player moving part, because already it's not gonna detect the balls. So let's see my expectation. It will be really difficult to detect the player also. In these times actually it was giving me some vectors, so now it's giving me really nothing. Even in here, let's see. Okay, it's not giving me any vectors because we set the threshold really low. Now let's make the opposite one. The default was 1, by the way, just keep in mind. Let's set it to the really high value. Let's say 100,000 maybe. And let's try again. Now my expectation is finding more motion vectors even for the ball. We missed one. Let's try. Now okay, it's giving me in here, but actually before that I see, if you just go back in the video, you are gonna notice there is vector in here before it's checked. Let's continue. Okay, not giving me anymore for the balls, but now even for this scene it's giving me vector. Let's run again because just wanted to show you again the difference with the default values. You see there is a vector, very correct vector is giving me in here for the ball direction, and one more I get in here. Yes, one more is giving. This is because of this forward backward, so we just increase the threshold, so it's gonna detect more motions in the video, in the scene. Okay, we already learned about this one. And this grid step is just about the size of the objects, which is in our case we can check easily. The default was 6 to 6. If we go to the documentation, let's see if there is any. Okay, there are some. For each grid motion vector is computed, some motion vectors will be removed due to the forward backward threshold. The rest will be okay. This is explaining the forward backward threshold. This set grid step size. Okay, this belonging to the interpolation, so there's no explanation for the grid step, but actually this is about the size of the object. So defaultly we are just setting this to the 6 to 6 defaultly, so we can change that parameter to the lower, to the smaller. For example, if we make it to 3 to 3 and we are expecting to see the ball's motion, because balls are also smaller. Also, this is getting only integer inside. No, it's getting the size of the OpenCV. Just set it to the 3 to 3. And now my expectation is seeing the, at least in some moments, seeing the result, seeing the output of the balls. Let's try. Also, maybe you notice or not, because I'm pressing to the key of my keyboard, is getting slower, because if you decrease the grid step size, it's gonna increase the it's gonna decrease the speed. Let's try more, but at least my expectation. Okay, in here you see there is a motion vector we see, so it's giving me some motion vector. In the default, in the 6 to 6 we can, because 6 to 6 representing about the pixels, means the kernel size about this parameter. This parameter is about the kernel size. So decreasing this is gonna detect more small object motions. Maybe we missed something here also. One more. Okay, one more vector I get here. So it's working as expected. So at the beginning we were not able to detect the balls. If your target is getting the small movements, you need to play with this grid step at the beginning, because this is directly arranging that parameter. Now we can get to the interpolation part. The default one is working fine, I think. Let's try to see in here. There are some interpolation type which is in here. Okay, the default was 1, which is interpolation epic, edge preserving, interpolating using LOF. And we can try this one instead of epic, which is 0, the enumeration value. So just get this one and set this. Just default was 1. Let's set it to the 0. And okay, set interpolation. Let's see again. So it should be in the same type. So for that we need to call optical flow and interpolation type. I didn't remember, but epic was the 0th one. No, this is one. Geo is the 0th one. Just call it. And the rig is the second one. Let's try again. Now we are trying with the 0th interpolation. Okay, already we missed something. Oh, so it's giving some Okay, maybe in some of the vectors it's giving me correct, but there are many noise in here around the moving. So because of the shadows of this ball maybe around is even affecting. So let's see the player case, but I can say I just feel, but don't need to measure, but this is faster than the other one, I can say. You see there are many noises, so this interpolation type, the noise is little higher. Let's try the other one, and this is rig, and let's try this one. Okay, this is little slower, I can say again. I feel that because yeah, also I see something here. There are many noise also for this one. Maybe I can say less than the previous one. Okay, I can say less than the previous one, but for our case, our scenario, I can say also the default one is working perfect. At least it's not giving me many noises, and that's why they are giving as default. This is better the second. This is the worst interpolation type for our scenario. Okay, now the last one we can talk about. This is about this is a Boolean parameter, I think. Yes. This is kind of also, we can say, is there any explanation here? There is no. Okay, this is also kind of refinement, means there is some smoothing algorithm working in behind. They are not giving this as default, which is 0. If we set it's to do true, let's see anything is gonna change or not. For our case, okay. Oh, this is just okay. Now let's see how it's working. In our scenario, I don't expect it will change many things also. Okay, nothing changed. Let's see the user case. Yeah, I don't see a clear also change. Let's see this part. Okay, it's not changing anything much, because also this kind of also smoothness. But the interesting part, this is coming as false. Most of them is coming as true, the default. This coming as false. Maybe it's also setting this to the true. If not changing anything in your cases, do not set, because I'm sure it's gonna increase the decrease the loop time of your code. Okay, actually I'm done for this video. We already talked about parameters. See you in the next videos.